Right, 1a, find the gradient between a and b. Straightforward formula. You should know this one. The gradient is difference in y's over difference in x, and that's the gradient of a straight line segment. Everybody should learn that. I should have just written it down. So between these 2 points, I'm going to call this one 1, this one 0.2. Okay, so the difference in y is 3, take away 10, over the difference in x is 12, take away negative 2. So that gives us minus 7 over 14, which simplifies to minus a half. 2 marks. Right, the next bit, find the equation of the line AB. Another formula you should have just learned, y minus y1 equals m, x minus x1. So you need to know the gradient, and you need to know a point on the line. You could use either A or B, doesn't make any difference. Remember, these two don't change. This bit, and this bit, you need to sub in. Same with here, you have to sub in those 4 bits. Here it's just 1, 2, 3. So y minus the y value, which was 3, oh no, I used the other one, sorry, 10, minus the gradient, a half, x minus 2. So y minus 10 equals minus a half times x plus 2. Instead of timesing this side by a half, let's just double everything, get rid of it. So doubled y becomes 2y, double minus 10 becomes minus 20. That leaves us with a minus 1 in front of that side. So I'm left with 2y minus 20 equals minus x minus 2. Doesn't ask for what form, so doesn't matter which way around. I'm going to make it 2y equals minus x, add 20 to both sides, plus 18, y equals minus a half x plus 9, divide both sides by 2. There you've got your equation of your line. Okay, second bit of the question then, part B. We've now got the line is perpendicular, intersects at the point 0, minus 1. The lines A and B intersect at the point D. So we might have to use what we've just done, but we'll scroll down. Let's have a little think about what this is going to look like. So it says the line L is perpendicular to AB and intersects the y-axis at the point minus 1. So, okay, well let's just draw that line we've just thought about. Let's have a little think about what this looks like. See what AB look like. Well, we could either just plot these 2 points. We know it goes through minus 2, 10 and 12, 3. So let's make that over here somewhere. So that's the point B, that's the point A. So that line made sense. It had a negative gradient. This line's going down. It was y equals minus a half x plus, it was 9, so it's y equals a half x plus 9. That means we know that one through at 9. So that's the line AB. Okay, it says that L is perpendicular to that, and L also goes through the y-axis at the point 0, minus 1. So it goes through at minus 1, which is probably down here somewhere. And it's perpendicular to this line. So I'm going to draw it just best I can, slightly perpendicular, almost anyway. So this is the line L. It goes through there, and it's perpendicular to that. You don't have to draw this sketch, but I'm just trying to give you a bit more understanding of what's going on. Okay? Because in the question it says write down, it means it shouldn't take you much work. Okay, so you don't need to do this, but we're just thinking about what it looks like. So write down the equation of L1. So we know for the equation of a line, our answer will probably be in this format, or might be in this format. Okay, but because they're saying write down, it means we don't need to think about it too much. We know the gradient. Remember, the gradient of this line is minus a half. So if it's perpendicular to that, yeah, it's, you know that if they're perpendicular, they multiply together to give you minus 1. You might know already that the negative reciprocal of that, if you like, is going to be 2. So the gradient of this second line is going to be 2. We also know the y-intercept is minus 1. Okay, so we know that C is minus 1. So for this second line, we can just write down that y equals 2m minus 1. And that's our second line. Nope, not 2m. Stupid. 2x minus 1. Okay, so we've got the gradient. We've got the equation of our line. Okay, if it says write down, you should be able to pluck it out of your brain somewhere. Okay, it says show that D has the coordinates 4, 7. D, go back to the question, was the point where they intersect. So this point just here. Where 2 straight lines intersect, simultaneous equations. So one of the equations we're looking at is y equals 2x minus 1. The other one was y equals minus a half x plus 9. Well, that's not too bad, is it? They both equal y, so I can make them both equal each other. I don't like this minus a half in there, so I'm going to times everything by negative 2. I'm going to times both sides by negative 2, gives me minus 4x plus 2x minus 18. Get rid of your smallest pile of x, so I'm going to add 4x to both sides. Add 4x to both sides, so that's going to give me 2 equals 5x minus 18. Add 18 to both sides, it's going to give me 20 equals 5x. Divide by 5, x comes out to be 4. Okay, if x equals 4, stick it back in one of the other equations, 2x minus 1, y equals 2 times 4 minus 1, which is 8 minus 1, which is 7. That's exactly what we're supposed to get in the question, 4, 7. So we get 4, 7. Find the length of AD and the length of BD. Right, so I'm going to squeeze that in here. You would not be advised to squeeze it in the exam. The length of a line is your Pythagoras-y kind of formula. That's where it comes from. Difference in the x's, difference in the y's, squared and square rooted. So the length of AD, okay, you've got your coordinates for A and D. A was minus 210, D was 4, 7. So you could have gone on and done this even if you'd mocked up everything else. So x1, y1, x2, y2, 7 take away 10 squared plus 4 take away negative 2 squared, square rooted. That's 3 squared, 9, or it's minus 3 squared is 9. 6 squared, 36. Square root of 45. You have a calculator that simplifies these for you, but it's 9 root 5, which is 3 root 5. Same process for the other one. What was it? BD? BD? B is the point 12, 3. D hasn't changed, it's 4, 7. So x1, y1, x2, y2. Stick them in. So the square root of 7 minus 3 squared plus 4 minus 12 squared. That's 4 squared, 16. That's 12 squared, 144. Square root of that's going to give you root 160. Which is... I've made a mistake somewhere. What have I done? 4 squared is 16. That's 8, isn't it? 4 minus 12 is 8, so, well, negative 8 is 64, so it's root 80. Okay? You're obviously going to have your calculator to check all of that. Oops, sorry, so you've got root 80 down there at the bottom. Okay. Done. Those first bits. The last bit of that question said the line CD is extended so that the point E is on the line, CD. Okay, where was C? Do we know where C was? Can't remember. So that so that D is the midpoint of CE. Find the coordinates of E. Write down the geometrical name for A, C, D, E. Right, so we must have this point C somewhere. The line C, okay, so C was this point down here, so I missed that off my diagram. C's down there, so CD is extended to the point E, so this is lengthened, so that D is the midpoint of CE. So whatever that distance there, I want it to be the same going the other way, so E will be up here somewhere. So this is where your diagram is really useful. We know that D was the point 47. Okay, so to get across from there to there, if you look at the x-coordinate here is 0, and it's gone across to 4, so it's gone across 4 units. So to get to E, if it's the midpoint, I have to do the same number of steps, so I've got to go across 4 again. So if this was 0, it's gone to 4, this is now going to have an x-coordinate 8. This is at minus 1, and it's gone up to 7, it's gone up 8 squares. So if I've got to go up another 8 squares, 7 plus 8 gives you 15. So E is going to be at 815. So part C, part 1, E is going to be 815. Okay, so if we've got, this is a midpoint here, A and B is perpendicular to that one. So this is the shape we're looking at. It's not the best sketch ever. But if we've got shape where our diagonals meet at 90 degrees, we have got the geometrical name for that shape is a kite. So the last bit of that one, CII